Hello my students, welcome back into my channel. In this video, I'm going to show you how we find the solutions of this exercise. Exercise 21G, integration by parts. Let's start with number 1. Use integration by parts to find integrals of the following functions with respect to x. Okay. 1a, integral x times e power x dx. Okay, for these integrations, based on the formula that integrations by parts, formula is integrals u integrals phi, derivative phi dx equals u times phi minus integrals phi derivative u dx. That's the formula for integrations by parts. That means u equals x, so derivative u equals 1, derivative phi equals e power x, and phi integrals e power x dx. E power x plus c. So it means this integration by parts will be u times phi is x times e power x plus c minus integrations phi, this one, e power x times 1 because derivative u dx. To separate, so x e power x minus plus c minus still e power x. So becomes x times e power x minus e power x plus c. If you would like to factorize, it can factorize being e power x times x minus 1 plus c. Now b integral x sin x dx. U equals x. Go down first. So derivative u equals 1. And derivative phi sin x. So phi integral sin x dx. Integral sin x equals minus cosine x plus c. Based on the formula, just a reminder that the formula integrals u times derivative phi dx, u times phi minus integrals phi times derivative u dx. So this integration being u times phi x times this expression. So x times minus cosine x plus c minus integrals minus cosine x times 1 dx. So minus x cosine x plus c minus being plus because this negative cosine x dx. becomes minus x cosine x plus c integrals cosine is sine. And you can write the conclusion minus x cosine x plus sine x plus c. C x squared ln x. Okay, for this integration, that u equals ln x, so derivative u equals 1 over x. And derivative phi x squared, so phi integrals x squared dx. It is 1/3 x cubed plus c. Just a reminder that the formula integrals u times derivative phi dx equals u times phi minus integrals phi derivative u dx. So u times phi ln x times 1/3 x cubed plus c minus integrals phi 1/3 x cubed times 1 over x, this derivative u dx. So it becomes 1/3 x cubed ln x plus c minus 1/3 integrals x squared, because x cubed over x becomes 1/3 x cubed ln x plus c minus 1/3 x cubed x, yeah, plus c already here. No need this one. So it is 1/3 x cubed ln x minus 1/9 x cubed plus c. This is the solutions. Or if you would like to factorize, it will be like this. And x minus 1/3 x cubed, like this. Yeah. Or comes 1/3 x cubed times ln x 1/3. You may factorize like this. D. Okay. X over x. And x over x. So u equals ln x. So derivative u equals 1 over x. And derivative phi is 1 over x. So phi integrals 1 over x dx equals ln x. Based on the formula that u times phi ln x times ln x plus c, this plus c actually, minus integrals phi ln x times 1 over x dx. ln x squared plus c minus integral ln x over x dx of yeah, this is integrals ln x over x dx. When we move here to the left, plus integrals ln x over x dx equals ln x squared plus c will be 2 integrals ln x over x dx equals ln x squared plus c, or comes it's here integrals ln x over x equals ln x squared over 2 plus c. Next, e integrals x 3 power x. Integrations that u equals x, so derivative u equals 1. Derivative phi, it means 3 power x, so phi integral 3 power x dx, and the result is 1 over ln 3 times 3 power x, yeah, plus c. Or we may simplify being 3 power x over ln 3 plus c, right? Based on the formula, u times phi, x times 3 power x over ln 3 plus c minus integrals phi, get 3 power x over ln 3 times 1. I'm going to separate first. Okay. So equals x times 3 power x ln 3 plus c minus, oh yeah, ln 1 over ln 3 integrals 3 power x dx would be x times 3 power x over ln 3 plus c minus 1 over ln 3. Going to scroll down, and this integrals, same with this integrals, the result, so 3 power x over ln 3 becomes x times 3 power x over ln 3 minus 3 power x over ln 3 squared plus c. Factorize, or you may factorize 3 power x over ln 3 times x minus 1 over ln 3 plus c. Okay. So one e. Now f. F. The question is x sine 3x. X sine 3x. So u equals x. So derivative u equals 1. Phi, derivative phi equals sine 3x dx. Sine 3x, I mean. So phi equals sine 3x dx. Minus 1/3 cosine 3x. So based on the formula u times phi. X times minus 1/3 cosine 3x. Plus c minus integral phi times derivative u. This derivative u. 1 times dx is minus 1/3 x cosine 3x plus 1/3 integral cosine 3x dx. Becomes negative 1/3 x cosine 3x plus 1/3, and this the integration is 1/3 sine 3x plus c is minus 1/3 x cosine 3x plus 1/9 sine 3x plus c. If you would like to factorize, you may factorize like this, minus 1/3 times x cosine 3x minus 1/3 sine 3x plus c. G x cosine 2x. Okay, so u equals x, so derivative u plus 1, and derivative phi cosine 2x. So phi integral cosine 2x dx. Half sine 2x plus c. So based on the formula u times phi, u times phi. So x times half sine 2x plus c minus integral phi minus half sine 2x times 1 dx. Half x sine to x plus c minus half integral sine to x dx will be half x sine to x plus c minus half times minus half cosine to x. Becomes half x sine to x plus 1/4 cosine to x plus c. Next h. X secant kuadrat x. Secant squared x. U equals x. Derivative equals 1. And derivative phi secant squared x. So phi integral secant squared x dx. It is tangent x. This on the formula u times phi x times tangent x plus c minus integral tangent x times 1 dx. So it is x tangent x plus c minus integral sine x over cosine x dx x tangent x plus c integral 1 over cosine x sine x dx. Through this integration, substitution integration, x tangent x minus ln cosine x plus c. This the result x tangent x minus ln cosine x plus c. Number 2, find integrals ln x dx by first writing ln x as 1 times ln x. B, hence find integrals ln x squared. Integrals ln x dx equals 1 times ln x dx. If u ln x, it means derivative u 1 over x. If derivative phi is 1, so phi equals 1 dx or x plus c. Based on the formula that u derivative v dx equals u times v minus v derivative u dx. This the formula. So it means u times v. The next times x plus c minus integral v x times 1 over x dx. X ln x plus c minus integrals 1 dx. X ln x plus c minus x or x ln x minus x plus c. B integrals ln x squared. This integrals ln x times ln x dx. If u ln x derivative u 1 over x derivative v ln x of v integrals ln x dx. It is based on these results, that's integrals ln x dx. So this one. So it is x ln x minus x plus c. I'm going to separate first and then u times v ln x times v x ln x minus x plus c integrals minus integrals of v x ln x minus x times derivative u 1 over x dx becomes x ln x squared minus x ln x plus c minus cross multiply first ln x minus 1 dx. So it is x ln x squared x ln x plus c minus integrals ln x dx plus integrals 1 dx. So next is integrals ln the result ln x ln x squared minus x ln x plus c minus integrals ln x. This one x ln x minus x, c already here, plus x ln x squared x ln x minus x ln x plus x plus x plus c. X times ln x squared minus 2x ln x plus 2x plus c. 3. Find integral arctangent x dx by first writing arctangent x as 1 time arctangent x. Similar with the previous question, number 2. Equals 1 times arctangent x dx. U equals arctangent x, so derivative u is 1 over 1 plus x squared. So derivative phi is 1. So phi integrals 1 dx equals x plus c. So becomes u times phi. Arctangent x times this one phi. Yeah. Times x plus c minus integrals phi x times derivative u. Okay. And next, x times arctangent x plus c minus integrals these integrations by substitutions. Yeah. 1 over 1 plus x squared times x dx. Arctangent x minus this is half. Okay. Now I'm going to show you how we find this integration. So if u 1 plus x squared, so du equals 2x dx, or half du equals dx. So it means this integration integrals 1 over 1 plus x squared dx can writing, x here, okay, can writing as yeah, half integrals 1 over u du, so it is half ln u plus c, or half ln 1 plus x squared plus c, this. So This integration being this 1 ln 1 plus x squared plus c. This is the solution. For integrate with respect to x. Okay. X squared e power minus x dx. U equals x squared. Derivative u equals 2x. Derivative v equals e power negative x. So v integrals e minus x dx. Minus e power minus x plus c. So based on the formula, just a reminder that integration by parts, u times derivative v dx, u times v minus integrals v times derivative u dx. This is the formula. So u times v is x squared times minus e power minus x plus c minus integrals v minus e power negative x times 1 to x dx. So it is minus x squared e power minus x plus c minus plus 2 times e power minus x dx. X here because this x. Okay, so we are going to find these integrals first. Okay. I'm going to use this space. So u equals x. So derivative u equals 1. V derivative v equals e power minus x. So v equals this one minus e power minus x plus 1 plus c. So we can writing being minus x squared e power minus x plus c plus 2 times, again, integration by parts, the second integration by parts, u times v, u times v, x times minus e power minus x. Plus c already here, minus integrals, integral u, integrals v minus e power minus x times 1 dx minus x squared e power minus x plus c minus 2x e power minus x becomes plus e power minus x dx. So minus x squared e power minus x plus c minus 2x e power minus x plus the integral minus e power minus x. See already here. Okay. I just now here. And 2, it means this is 2 times, yeah, 2 here and 2 here. Minus x squared e power minus x minus 2x e power minus x minus 2 e power minus x plus c. Yeah, that's one. B e power x cosine x. Okay. I would like to use another color. E power x cosine x dx. U is cosine x, so derivative u equals sine x minus sine x. So derivative phi e power x, so phi integral e power x dx, the integral e power x plus c. Based on the formula, u times phi cosine x times e power x plus c minus integrals phi derivative u yeah, so it becomes e power x cosine x plus c minus being plus e power x sine x dx. Right. I'm going to describe this as the second uh, integrals by parts. Yeah, u equals sine. Yeah, u equals sine x. Derivative u equals cosine x. And derivative phi is e power x. So phi, same with this one, plus c. So it becomes e power x cosine x plus c plus u times phi. U times phi sine x times e power x minus integrals v e power x times u cosine x dx. It will be e power x cosine x plus c plus e power x sine x minus integral e power x cosine x dx. Or I can writing that integrals e power x cosine x dx equals this e power x cosine x plus e power x sine x minus integrals e power x cosine x dx plus c. So this part will move to the left. So it becomes, gonna move here, integrals e power x cosine x dx plus minus being plus e power x cosine x dx equals e power x cosine x plus e power x sine x. So becomes 2. 2 times e power x cosine x dx e power x times sine x plus cosine x, or integrals e power x cosine x dx half times e power x times sine x plus cosine x plus c. Okay, that's for B, and for C, e power minus x sine x. I'm going to using another color, this color. For C, e power minus x sine x dx. So u equals sine x, derivative u equals cosine x, derivative v e power minus x, and v integral e power minus x dx minus e power minus x plus c. Just a reminder that integrals u v derivative u times v minus v times the derivative u. Yeah, like that, the formula. So u times v, u times v. Sin x times minus e power minus x plus c. minus integros v minus e power minus x times derivative u cosine x dx. Okay. Comes minus e power minus x sine x plus e power minus x cosine x dx. Okay. And then after that, I will I'm gonna find this the second integration by parts here. U equals cosine x. So derivative u equals minus sine x. Derivative v equals e power minus x. So v same like this, minus e power minus x plus c. It comes minus e power minus x sine x plus the second integration by parts, u times v. U times v, it means cosine. And cosine x times minus e power minus x plus c minus integrals minus e power minus x times minus sine x dx. So equals minus e power minus x sine x. And this is minus e power minus x cosine x plus c minus being plus or being minus 1, 2, 3, 3 minus, so e power minus x sine x dx. So we can writing that integrals e power minus x sine x dx equals minus e power e minus x minus e power minus x sine x minus e power minus x cosine x minus integrals e power minus x sine x dx plus c. So these integrals will move to the left, to here, to this side, being integrals e power minus x sine x dx plus e power minus x sine x dx minus e power minus x, factorize, sine x plus cosine x plus c becomes, I'm going to move here, 2 integrals e power minus x sine x dx equals minus e power minus x sine x plus cosine x plus c, or integrals e power minus x sine x dx minus half e power minus x times sine x plus cosine x plus c. X. Okay, we see already. Now D. Question is x squared sine x. Okay. Okay. Next, u equals x squared. So derivative u to x, and then derivative phi sine x. So phi integral sine x dx minus cosine x u times phi x squared times minus cosine x plus c here minus integrals minus cosine x times 2x dx is minus x squared cosine x plus c plus 2 times x cosine x dx. So the second derivative, I'm going to find here. Okay. Especially for these integrals. So u equals delta is, yeah, I'm going to involving u here to x. So derivative u2 cosine x and derivative and phi equals integrals cosine x sine x. So becomes minus x squared cosine x plus c plus u times v to x times sine x to x times sine x. See already here. Plus v sine x times 2. Okay. Dx comes sine x plus c plus 2x sine x minus 2, and integral sign is cosine minus cosine. Minus x squared cosine x plus 2x sine x being plus 2 cosine x plus c. Okay, next for e. For e, I have to clean first this area. Wait. Okay, let's be doing number 4e. For e, this integral. So I would like to start with e. Better if you're writing being the next word times 1 over x squared dx. So u equals the x squared. So derivative u being 2 ln x times 1 over x. And derivative v x power minus 2. So v equals minus x power minus 1 plus c. Okay. So u times v ln x squared times minus x power minus 1 plus c to gross minus x power minus 1 times this one derivative times derivative u. Okay. Okay, this is minus 1 over x. So it becomes minus ln x squared over x. Okay, plus c minus our being plus 2 plus 1 over 43. It means 1 over x. This 1 over x squared because times x. Ln x dx. Okay. We have to find the second part integration, the second part of integration by parts. U is ln x, derivative u 1 over x. So derivative phi is 1 over x. Yeah. 1 over x squared. So phi equals plus 1, yeah, 1 minus this plus 1 is negative 1, yeah, minus 1 over x. That so becomes minus ln x squared over x plus c, then plus 2 times ln x times 1 over x minus integrals 1 over x times 1 over x dx. Okay, so it is ln x squared minus x plus c plus 2 times ln x integrals 1 over x squared. Yes, 1 over this is squared 2 over x then x minus minus 2 times minus 1 over x. Yeah, let's see. x, 2 ln x for x, plus 2 over x. Okay, I have to clean this area first. Okay. It comes. Oh, I have to clean first. This. It will be minus ln x squared plus 2 ln x plus 2 over x plus c. That's for E. Okay, next, number 5. Number 5, use integration part by parts to find integrals u squared e power u du. Hence, find integral ln x squared dx using the substitution u equals ln x. Okay. Integrals u squared e power u du. If u equals u squared, so derivative u equals 2u, and derivative v e power u, so it means v is integrals of e power u du equals e power u plus c equals, just a reminder that the formula of integration by parts, integrals u derivative v minus u times v equals u times v minus integrals v times derivative u dx. So u times v, u is u squared times v e power u plus c minus integrals e power u times derivative u times 2u du equals u squared e power u plus c minus 2 integrals e power u times u du. And next, the second integrations by parts. Use this space. If u equals u, this u, okay, so it derivative u equals 1, derivative v is e power u, so v equals integrals e power u du equals e power u plus c. So it becomes u squared e power u plus c minus 2 times u times phi, u times this, u times e power u, let's see already here, minus integrals phi e power u times 1, the u. So it becomes u squared e power u plus c minus 2u e power u minus integrals e power u, still e power u. It is u squared e power u minus 2u e power u minus e power u plus c. B, find this integral, learn x squared. Just now at number 2, we already found this integrals, but we are going to using the difference approaching through substitution. I'm going to use another color. Okay, integral then x squared dx. If u equals ln x, we can state that x equals e power u. So the x equals e power u du. So this integrals we can writing that this is u, so u squared, and the x this one, it means e power u du. Okay, we are going to find the integrand by integration by parts. So if this u equals u equals u squared, so derivative u equals 2u, and phi derivative is e power u, so phi is integrals e power u du equals e power u plus c. So becomes u times phi, u times phi, u times phi, u squared times e power u, then minus integrals phi, this one, e power u times derivative u to u du. So it is u squared times e power u minus 2 minus 2 integrals e power u times u du. Now we are going to find the second integrals by parts. I'm going to use this space. The space. u equals u, this u. So derivative u equals 1. Derivative v, e power u, and v integrals e power u du. So v equals e power u plus c. So these integrals being u squared e power u minus 2 times u times v, u times e power u minus integrals v, this one, e power u, v times derivative u times 1 du. Becomes u squared e power u minus 2u e power u minus still e power u, or times 2 here, plus c. Recall that u squared is ln. Here u is ln x, so it is ln x squared, and e power u is x, ln x squared times x minus 2 ln x times x, because e power u equals x, this one, minus 2x. So the final result, x ln x squared to x ln x minus 2x. Number 6, find integral sine x cosine x dx using double angle formula, substitution, and integration by parts. A, by double angle formula. Cosine x equals sine 2x. So sine x cosine x equals half sine 2x. So we're going to using this this expression to find this result. So it means integral sine x cosine x dx integrals half sine 2x. Comes half integral sine 2x dx. Okay, if by substitution, this one is if u equals to x, it means the u equals to the x, or half the u equals the x. So this integral will be sine u times the x equals half the u times half du, or being half times half, quarter, sine u du, quarter times minus cosine u plus c, or a quarter times cosine 2x plus c. Now, by substitution, by substitution, integral sine x cosine x dx. If u equals sine x, so du cos cosine x dx, it means this is du. So this integral being u du. So being half u squared plus c. Recall that u equals sine x. Half times sine squared x plus c. Or becomes half times sine squared x plus c. Okay. Next, by integrations by parts. Okay. U equals sine x. So derivative u equals cosine x. Derivative phi cosine x dx. So phi integral cosine x dx. Minus, not minus, but sine plus sine x plus c. So this integral being u times phi sine x times sine x minus plus c minus integral sine x phi times derivative u cosine x dx. Comes sine squared x plus c minus integral sine x cosine x dx. So this part will move to the left, join with this part. This term becomes integral Sine x, cosine x, dx, plus integral sine x, cosine x dx, cosine squared x plus c. 2 integral sine x, cosine x dx equals sine squared x plus c, integral sine x cosine x dx, half sine x sine squared x plus c. Number 7. Use integration by part to find integral sine for x cosine x dx. So u equals cosine x. It means derivative u equals minus sine x. So derivative v sine for x. So v integral sine for x dx. It is minus quarter cosine for x plus c. So it means integral sine for x cosine x dx based on the formula u times v. Cosine x times minus quarter cosine for x plus c minus integral v minus a quarter cosine for x times u, not times derivative u, I mean, minus sine x dx becomes minus quarter cosine x cosine for x plus c positive times negative being negative. Quarter cosine for x sine x dx. Right. I'm going to create another integration by parts. For this integral, u equals sine x, derivative u equals cosine x, derivative v cosine for x, so v integral cosine for x dx is becomes a quarter sine for x plus c. So it becomes, it will be longer, so I will start from here. Okay. Sine for x cosine x dx minus a quarter cosine x. Cosine for x plus c minus quarter times u times phi. Sin x, okay. Sin x times phi, a quarter sine 4x minus integral quarter sine 4x times cosine x dx. It becomes minus a quarter cosine x cosine 4x plus c minus a quarter, 1 over 16, because 4 times 4 sin x sine 4x minus a quarter integral becomes positive here because minus sine 4x cosine x dx plus c. C already here. No need this c. Now, this term, we're moving to the left. I'm going to put here. So at the left side being integral sine 4x cosine x dx minus this is 16 as well, 1 over 16, because 4 times 4, okay? Yeah. Minus 1 over 16 integral sine 4x cosine x dx minus 1/4 cosine x cosine 4x minus 1 over 16 sin x sine 4x plus c. This is 1 minus 1 over 16. 16 over 16 minus 1 over 16 being 15 over 16. Well, sine 4x cosine x dx equals minus 1/4 cosine x cosine 4x minus 1 over 16 sine x sine 4x plus c. That times, multiply by 16 over 15. All parts. This part being sine, integral sine for x, cosine x dx, and this part being minus 4 over 15 cosine x, cosine 4x, this part being 1 over 15 sine x, sine 4x plus c. It is, I'm going to factorize minus 1 over 15 times 4 cosine x, cosine 4x plus sine x, sine 4x plus c. Eight, use integration by parts to find integrals u sine u du. After that, find integral sine square root 2x dx using the substitutions u squared equals to x. Okay. Integrals u sine u du. If u equals u, I mean this u, this one. So derivative u equals 1. And it means derivative phi is sine u. So phi equals integral sine u du. It is minus cosine u plus c. Based on the formula of integration by parts, u times phi, u times phi. So u times minus cosine u plus c minus integral phi minus cosine u times derivative u 1 du comes minus u cosine u plus c being being plus, sorry, plus cosine u du. So minus u cosine u plus c plus sine u. So the integral outcomes minus u cosine u plus sine u plus c. Okay, B. I'm going to use another color. Integral sine square root 2x dx. So substituting u squared equals to x. It means x equals half u squared. So the x equals u du, 2 times half. So it becomes integral sine sine square root u squared times u du, because the x equals u du. So it becomes here. Yeah. Integrals u sine u sine integrals u sine u, because square root of u squared du. This is the integrals u sine u, this one, minus u cosine u plus sine u plus c minus square root to x cosine cosine square root to x, because u equals square root to x, plus sine square root to x plus c. That's next 9. Find integral cosine 3x dx using the substitutions u squared equals 3x. If u squared equals 3x, it means u equals square root 3x and x equals 1/3 u squared. So the x 2/3 u. That's the x. Yeah, of course, the u. So integral cos sine square root 3x dx. It is equals cosine square root u squared 2/3 u du. This one, because of this one. So it is 2/3 integral u cosine u du, because square root u squared, right? We're going to find this integration by parts. From this integration, from this integrals, u equals u. So derivative u equals 1, derivative phi cos u It means phi integral cosine u du. It is sine u plus c. So becomes 2/3. Based on the formula u times phi. So u how much? U equals u. Okay. U times this is phi sine u plus c minus integral phi sine u times 1 du. So it is 2/3 u sine u plus c minus integral sine u minus cosine u. So 2/3 times u sine u plus cosine u plus c. Becomes, multiply 2/3 u. U is square root 3x. U is 1. Yeah. So square root 3x sine square root 3x plus cosine square root of 2/3 here. 2/3, okay, cosine 3x plus c. That's the solution.